Section 6.5. Full testing example. Let's try a problem that we might need to solve to help students decide where to sit in in-person classes. Although we're talking about finding empty seats in a classroom, this problem is the same as trying to find the number of empty seats in a concert hall, theater, movie theater, or office layout. Suppose we have the classroom layout as a two-dimensional list with rows of seats. Each seat either contains a space, empty space, or a student, S, to represent an empty or occupied seat, respectively. We're going to ask Copilot to create a function to determine which row we could add the most students to, and along the way, we'll design the tests needed to check whether the code is working properly. Section 6.5.1. Finding the most students we can add to a row. We want to figure out the largest number of new students we could add in a single row in the classroom. Equivalently, we're looking for the largest number of empty seats in any row. For this, let's start with a somewhat ambiguous prompt and see how well Copilot does.
Listing 6.4. Largest number of students we can add to a row.
For the sake of this example, our prompt wasn't very good. How many new students can sit in a row is a reasonable starting point to give to a human, but it's not that specific, and it's easy to imagine Copilot struggling to interpret what we mean. Copilot might get confused about whether we're counting the number of students or the number of empty seats in a row, or it might return the total number of available seats in the classroom rather than in a row. It turns out that our prompt confused Copilot, and the code isn't correct. But before we dive into the code, let's think about what tests we should run. We've come up with the following set of test cases. A classroom with some number of consecutive empty seats and some number of non-consecutive empty seats to make sure it isn't just counting consecutive empty seats. A classroom with no empty seats to make sure it returns 0 in that case. A classroom with a row full of empty seats to make sure all are counted, including the first and last seats, edge case. A classroom with multiple rows with the same number of empty seats to make sure it returns just one of those values, and not perhaps the sum of the number of empty seats across all of these rows. Let's start by adding the first test case and adding the doctest code to run the test, as shown in the following listing.
Listing 6.5. Largest number of students we can add to a row.
When we run this code, we get this output. We cleaned up the formatting of the classroom list manually to help with the readability of the answer.
See this code?
Although we'd prefer the code to work, we appreciate that the first test case found an error. The row with the most empty seats is the third row with 4 seats available. But the code from Copilot is incorrectly telling us the answer is 6. That's pretty odd. Even without reading the code, you might hypothesize that it's counting either the number of seats per row or the maximum number of students seated per row. Our test case had a full row of students in the second row, so it's hard to tell. What we can do is change the classroom to be
See this code?
So the second row now has 5 students. When we run the code again, the test again fails with the code giving us an answer of 5. It seems that the code isn't just telling us the number of seats per row. It must be doing something related to where students are sitting. Our next step is to improve the prompt and determine whether we can get better code from Copilot. But for completeness, let's first explain what the code was really doing in the following listing.
Listing 6.6. Walkthrough of the incorrect code from Copilot.
You can see from the code description what is happening per line, but at a high level, this code is counting the number of consecutive students in each row. It does this by initializing a counter to 0 for each row and then incrementing that counter as long as it keeps seeing a student in a seat. It also resets the counter as soon as it sees an empty seat. The if statement at the end of the inner loop is a pretty standard way of keeping track of the largest of something seen before, and in this case, it's keeping track of the largest number of consecutive students seen. That's not at all what we wanted, and our poor prompt is partially to blame. The key piece, though, is that our test lets us know the code is incorrect. If you spotted the error yourself in reading the code, that's great too. Section 6.5.2. Improving the prompt to find a better solution. Let's rewrite the prompt, keep the test case, and see whether we can do better in the following listing.
Listing 6.7. Trying again to find the largest number of students.
To get this solution, we had to look through the possible Copilot solutions using Control-Enter. Some of the solutions now counted the consecutive occurrences of empty space, whereas others, like the one in listing 6.7, passed the doc test. Oddly, The first time we tried the improved prompt, the suggested solution was correct. This is another reminder of why non-determinism in the Copilot output makes testing so important. Let's take a minute and look at what made this second prompt better than the first. Both prompts had
See this code.
the part of the prompt that led to us receiving the wrong answer was
See this code?
the part of the prompt that yielded a correct answer was.
See this code?
You can never really know why a large language model, LLM, like Copilot, produces the answer it does. But let's remember that it's trained to just make predictions of next words based on the words it's been given and words that were in its training data. That is, lots of code in GitHub. The first prompt asks Copilot to make some inferences, some of which it does well, and some not so well. The prompt, in a sense, is asking Copilot to know what a row is in a list of lists. Thankfully, that's really common in programming, so it had no problem there. Then, the prompt asks Copilot to make the basic logical step of inferring that an empty seat is where a new student could sit. Here is where Copilot struggled. We suspect that because we're asking about new students sitting in a row, it wasn't able to make the jump to realize that new students would require figuring out how many students you can add, or, in other words, how many empty seats there are. Instead, Copilot focused on the students ... in a row part of the prompt and started counting students in each row. It could have also used the function name, which, admittedly, could be better, that is, max empty seats per row, to think it needs to count the maximum number of students. That's not what we want, but we can understand how Copilot makes this mistake. Now let's talk about why, in response to our vague first prompt, Copilot decided to count consecutive students in a given row. Maybe counting consecutive students is a more common pattern in Copilot's training data. Maybe it's because sit in a row could be interpreted as sit consecutively. Or maybe it's because when we were coding this example, we'd been working on another version of the problem that asked for consecutive empty seats, and Copilot remembered that conversation. We don't know why Copilot gave us this answer, but we know that our prompt was too vague. In contrast, our second prompt was more specific in a few ways. First, it clearly asks for the maximum. Second, it asks for the number of spaces or empty seats in a row. That takes away the need for Copilot to infer that an empty seat means a spot for a new student. We also used total and given row to try to get Copilot out of its current approach to counting consecutive values, but that didn't quite do the trick. Consequently, we ended up having to sift through Copilot answers, using Control-Enter, that were sometimes looking for consecutive empty seats, and sometimes finding the count of empty seats. Section 6.5.3, Testing the New Solution. Returning to our example, because the new code passes the current test, let's give it more tests to ensure that it's behaving correctly. In the next test, we'll check that the code properly returns 0 when there are no empty seats in any rows.
See this code?
The next test will ensure that the code properly counts all 3 empty seats in a single row, here, the second row, so there isn't an edge case problem. For example, it fails to count the first or last element. Admittedly, looking at the code, we can see the count function is being used, and because that function is built into Python, we should be fairly confident this test will pass. However, it's still safer to test it to make sure.
See this code?
The last test checks to see that Copilot properly handles the case that 2 rows have the same number of empty seats.
See this code?
After adding these test cases, we again ran the full program, shown in the following listing, and all test cases passed.
Listing 6.8. Full code and doc tests for largest number of students.
In this example, we saw how to write a function to solve a problem from start to finish. Copilot gave us the wrong answer, partially because of a difficult-to-interpret prompt. We figured out that it gave us the wrong answer because the code failed on our first test. We then improved the prompt and used the code reading skills we learned in the previous 2 chapters to pick out a solution that looked correct for our needs. The new code passed our initial basic test, so we added more test cases to see whether the code worked in more situations. After seeing it pass those additional tests, we have more evidence that the code is correct. At this point, we've tested the common cases and edge cases, so we're highly confident that our current code is correct. Regarding testing, this example showed us how tests can help us find mistakes and give us more confidence that the code will function properly.